All right, so we've talked about case 1, case 2, and now we're going to talk about case 3. Case 3, when it comes to horizontal asymptotes, case 3 is when the highest degree in the denominator, in this case x cubed, is the same as the highest degree in the numerator. And this is also an x cubed. And in this case, it's simply the ratio of these coefficients. So 1 over 3 would be your horizontal asymptote. Why is that true? Why is it 1 over 3? Remember we said before that asymptotes, horizontal asymptotes, occur as x goes to infinity. So if you were to take this right here and plug in infinities wherever we saw an x, here's what would happen. We'd have infinity cubed plus 4 infinity squared over 3 infinity cubed minus 6 infinity squared. Again, I'm taking this equation, plugging in infinities. Why? Because that's where x is going when you're talking about horizontal asymptotes. Okay, remember that infinity, the bigger the infinity, the more it's going to dominate. So up here, infinity cubed is way bigger than infinity squared, so we don't even care about that. You know, it's like adding infinity plus 7. Infinity is so much larger, who cares about the 7? So this really is the same as infinity cubed. Down here, same thing. These lesser infinities are dominated by the 3 infinity cubed, because cubing is bigger than squaring or raising to the first. So how would you do this if it was just x cubed over 3x cubed? Well, you would probably cancel the x cubed and you'd be left with 1/3. That's exactly what we can do here. We would get 1/3. That's why the horizontal asymptote is 1/3. So that's just to kind of show you where that comes from. And again, this is a case 3. Case 3, it doesn't matter how you number them. You could have called one of the other ones case 3, but this is just how we've chosen to number it here. All right, so let's graph y equals 1/3 as the asymptote. So this red line is roughly 1/3 right there. It's pretty close. Obviously, if we were kind of zoomed in more, we could be more exact, but that's that's close enough. So let me erase this right here, and then so our first step is to factor. I know we're going out of order here, and really, again, these should be reversed. It's better to find the asymptotes first. So let's factor. The top has a common factor of x squared, and we pull out an x squared, we're left with x plus 4. The bottom has a common factor of x, and when we pull that out, we're left with, actually, I'm sorry, it has a common factor of 3x. When we pull out the 3x, we are left with if you divide this by 3x, you'd be left with x squared. This divided by 3x is minus 2x, and this divided by 3x is minus 3. So then we could even factor that more. We could have x squared times x plus 4. The 3x is still here. And then what multiplies to negative 3 and adds to negative 2? That would be x minus 3, and then x plus 1. Okay, so we've factored. Now let's find the asymptotes. We already found the horizontal asymptote. That was y equals 1/3. The vertical asymptotes are anything that makes the denominator 0 unless we have a whole. So we're actually going to have both of those. In this case, we'll have both a whole and a vertical asymptote. So the vertical asymptotes, there's two. X equals -1 is a vertical asymptote because that makes that one 0. X equals 3 is a vertical asymptote. So let's draw each of those. So -1 is going to be right here. That's x equals -1. And positive 3 is going to be right here. So notice, because we have two vertical asymptotes, we're going to have 3 parts to our graph. We're going to have something over here, something in the middle, something over here. Okay, and then a hole. I said there was going to be a hole. Why would there be a hole? Because although it looks like x equals 0 would be a third asymptote, notice that you can cancel that and one of these up here. So x equals 0 does make the bottom 0, but because it's able to cancel right there, we're going to have a hole in the graph at x equals 0. How do we find out what the y-coordinate is at that hole? Plug in 0 here, plug in 0 here, plug in 0 here. When you do that, the top is 4. 0 plus 4 is 4. And the bottom is going to be 3. That 3 right there times, if you plug in 0, 3 times -3 is -9. And -9 times, that's going to be 1, would be -9. So we have a point at 0, -4/9. So let's put that in here. So 0, -4/9 is going to be, let's say, roughly about right there. Approximately right there. That's not a perfect picture, but it's going to get us fairly close, I think. So let's verify that actually we did that correct, I think. Let's see. Oh, you know what? I'm sorry. Sorry. Y does not equal negative 4/9. I plugged in 0 to all the x's, but I forgot to plug it in right there. So it's actually going to be 0 times everything else, and that's just going to be 0. So that whole should actually be not at 0, negative 4/9, but at 0, 0. So let's fix that. Okay, so here's our asymptote. So we're going to have a hole right there at 0, 0. All right, so we've got the asymptotes. We have the holes. Now let's get the intercepts. So we need the x-intercepts, and those occur when y equals 0. And we need the y-intercepts, which occur when x equals 0. Okay, so when x equals 0, let's just plug in 0 here. So the top will be 0. The bottom will also be 0. And that's impossible. We have 0 over 0, so there are no y-intercepts. We can already tell that there's a hole at 0, 0. So that's not going to work. Okay, then what about the y-intercepts? So there's two ways we can make the top 0. We can make that equals 0, but we already said that doesn't work. X can't be 0. There's a hole there. Or we can make this equal to 0 at negative 4. So let's try that. So if we plug in x equals, let's simplify this. If we plug in x equals negative 4 right here, so that's going to be negative 4 squared. Okay, I'm sorry. My mistake. It's just going to be negative 4. We don't need to plug it in because we already know that y equals 0. So this is going to be the point y equals 0, x equals negative 4, and that will put us on the graph at negative 4, 0. That's going to be right here. All right, so now we've taken care of these. Now notice we have 3 regions to this graph, so we're going to need, step 4 is going to be important here. We'll have to make a fairly substantial table of values. So let's start over here. I'm just going to call this region 1. We'll call this region 2, and this region 3, because we're going to have 3 regions. So let's start with the x values in region 1, and I already have 1 at negative 4. Let's get close to that asymptote. That asymptote's at negative 1, so let's plug in negative 2. So if you plug in negative 2 here and here, the top is going to be, what's that going to be? 4 times 2. The top will be 8, and that's going to be over, and I'm plugging in negative 2 up here. The other one is going to be negative 6 times negative 5 is 30. 30 times negative 1 is negative 30, so that comes out to be about negative 4/15, I believe. Negative 4, so negative 2, negative 4/15 puts us roughly right here, and that means our graph is going to kind of go down like so, and then it's going to get really close to that asymptote going this way. So that's our first region right there. Let's get the region 3 first, because region 2 is a little bit different, so I'll show you why. So region 3, we don't have any points there. We do have an asymptote right here at x equals 3. So let's pick x equals 4 and x equals 5 as our 2 points. Okay, again, if we plug in 4 to this original equation right here, we'll have, what's that going to be? 16 times 8 is 128. I'm just doing some mental math. You can plug this in a calculator in general. It makes it a little bit faster. The bottom is going to be 5 times 1 is 5 times 12 is 60. So that turns out to be roughly 2 and 4/15. So what's that? That's about 2.2, let's say, or 2.3. I'm doing this out of calculator, so it's not going to be exact, but that's about right there. Let's get one more point, so we'll plug in 5 as well. So the top 5 times 9 is going to be, actually, I'm sorry, 25 times 9 is going to be 225. And then the bottom is going to become 15 times 2 is 30 times 6 is 180. So that is going to be, what's that, 1 and 1/4, about 1.25. So that is going to put us right here. Well, now we have those 2 points. Now we know that if we connect them, it has to go this way. And if we go in this direction, it must be going up like that. So we have 2 regions. Let's get the third region. And the third region, we already have a point in that region, but to make it as exact as possible, let's get a point to the left of 0 and a point to the right of 0 as well. So we have a point right now at 0, 0, and we can't hit negative 1 because there's an asymptote at negative 1. So let's plug in negative 0.5. And then if we go a little to the right of 0, let's go, here's 2 right here. We run into an asymptote at 3, so let's put in 2 as well. And that will help us get a pretty good picture. So if we plug in 2 first, that's a little bit easier. We'd have 4 times the top is 6. Again, I'm just taking 2 and kind of mentally plugging it into this. You can save time with a calculator if you want. The bottom is going to be 6 times negative 1, negative 6. Negative 6 times 3 is negative 18. So that turns out to be negative, and I believe that's negative 1 1/3. So 2, negative 1 1/3 is going to be on our graph, and that's going to put us right here approximately. So we know that when we connect the points right here, the line is going to go down this way. We don't know what it's going to do on the other side. It could swing around and go down. It could go the other way. So negative 0.5, that's a little bit tricky to do that without a calculator, so I'm going to try it, but double check too to make sure we don't make a mistake, or I don't make a mistake. So let's do negative 0.5 being plugged in right here. So negative 0.5 squared is 0.25. Negative 0.5 plus 4 is 3.5. And then on the bottom we're going to have 3 times negative 0.5 is negative 1.5. And then when we plug it into the rest, negative 0.5 minus 3 is negative 3.5. And then finally negative 0.5 plus 1 is going to be 0.5, positive 0.5. So these will cancel, leaving us with negative 1 there. This reduces to 1, that reduces to 6, and actually that negative and that negative cancel. So we're left with 6 times 0.5 is 3, so that's the same as 1/3. So as far as I know, I did that right, but we could always double check. Actually, that can't be right because 1/3 is our, oh no, it can be, I'm sorry. 1/3 is our horizontal asymptote. That's okay though, because it is allowed to cross the horizontal asymptote in the middle of this graph. It cannot do it over here or over here as we're going to infinity. So notice we cross, so now it means we're going up, and that's what the graph looks like. There are 3 regions, region 1, 2, and 3, and we found them again by using our 4 steps.